Hey, good morning. We're going to take a look at solubility here. So, my camera is a little bit in the way here, but we'll work with this. All right. So, we're taking a little bit of a screenshot here. When we're looking at solubility, what we're trying to predict is, or solubility rules, we're using the solubility rules to predict if, when we take this right here, so if we were to go ahead, these would break down here into different ions here. Al, SO4, Ba would be plus 2, Cl minus 1. These ions here, if I have these in two different containers here, and then I mix them together, and these are in, it says here aqueous solutions here. So that means that they're going to be dissolved in water. If I take these and put them into one container here, I'm going to have all of these ions floating around. That's what happens when you dissolve something, is that's ionically bound together, is that it's going to break apart in water into its individual ions. Now, what can happen here is that some of these ALs can combine with some of these chlorines, or there's also the potential for some of these bariums to combine with some of these sulfates. So if they find each other and they are insoluble, they're going to form a precipitate, much like this here. So this right here, you can see in this one here, the precipitate is formed at the bottom here. So something like this could happen. Or if any combination of the ions, or if every combination of the ions is going to be soluble, then you're not going to get a reaction. So you'll have something that looks like this, where it's still see-through and there is no precipitate formed. Let's use our solubility rules to predict if we'll get a precipitate from this reaction here of aluminum sulfate plus barium chloride. So if these were to switch partners here in a chemical reaction, the aluminum here would bind with the chlorine and the barium would bind with the sulfate. So then we would have barium sulfate plus aluminum chloride. All right, and then we check over here. So the endings here. So we're going to use the Texas Star solubility chart here. So this is what you'll get on your final. When you take it at the end of the semester, you'll get a chart like this, and you'll use it to figure out if you're going to form a precipitate or not. So in this one here, we're going to check for SO4 and chlorine. So SO4 is right here, and here's chlorine. Notice they are both on the soluble chart. So they are on the soluble one, not the insoluble chart. So when we read this thing, we're going to read this as chlorine is soluble, except we're going to look at these exceptions here. Chlorine is soluble except when combined with Ag, Pb, and Hg. Sulfate is also soluble except when it's bonded with, when it's made an ionic bond with strontium, barium, lead, or Hg. So here the chlorine here, aluminum, is not on this exceptions list, so this is going to be soluble. Sulfate, on the other hand, SO4, is with a barium, with Ba, and it is on our list right here. So what this is saying here is that sulfate is soluble except when attached to barium. So this is going to be not soluble, but it'll be the opposite. It will be insoluble. So that means that this here is going to make a precipitate. So BaSO4 is going to make something like this at the bottom, whereas AlCl3 is still going to be in solution here. It's not going to make any precipitate. So here, identify if any products will form a precipitate here. The rest of the problem's cut off there. It's covered up on my chart. But BaSO4 will form a precipitate. Now, this will not always be the case. So if you have a problem like this one here, it's not there right now. Let me go ahead and grab that problem. So this problem right here, all this. Okay. These here, if these were to mix switch spots here, this would be ZnI2 plus HNO3. And if we take a look here, let's check for iodine and NO3. Iodine here is soluble except when attached to silver, lead, or mercury. It's not attached to silver, lead, or mercury here, so this will be soluble. HNO3, on the other hand, though, HNO3, the NO3 here has no exceptions. NO3 will always be soluble no matter what it's attached to. So that's going to be soluble as well. So if we see a case like this, no reaction is going to occur. What would happen then is we would get a reaction here that looks similar to this here, where there is no precipitate formed. So in this case here, but in both of these cases here, if they were to switch partners, nothing would precipitate out. So no reaction. Would occur, and no precipitate would form here. All right? And those are the two different cases that we're going to have here. Either something, when they switch partners, is going to form a precipitate, or no reaction will occur and no precipitate would form if any combination of the ions, if any combination of the ions is still going to be soluble. All right? Thanks for watching. See if you remember how to turn this off.